Okay, so my last stoichiometry video I think maybe was a little overwhelming. I haven't even posted it yet, but after thinking about what I did, I think it's helpful, but to start out, I'm gonna slow it down a little bit. So here's a good starting point for stoichiometry, especially if you missed one or both of the lectures. So in stoichiometry, it's like cooking, but for chemistry. And so when we're cooking or baking something, we need a good recipe. We need to know our ratios. And even if you're one of those phenomenal cooks that doesn't use a recipe, you still have to know the right ratios, right? You can't do something crazy. That's what makes you a good cook, though, is that you already know them in your head, which makes me a good chemist because I already know a lot of the ratios for chemicals in my head, right? So I can balance equations pretty easily. So that being said, whenever we're doing it for chemistry, we have to have those right ratios. And how we do that is by a balanced equation. So the first thing that you need to make sure that you can do before you try stoichiometry is make sure that you can balance equations. And so for all of those problems, every single time you're gonna need a balanced equation when you're working them. So you need to be able to write them. You need to be able to figure them out from your name. So if I say sodium chloride reacts with water or whatever, and so then you can write like sodium chloride NaCl, and then you can write water and you can balance the equation based off of that. Okay, some terms. So we know how to use molar mass. You should feel comfortable using molar mass going from grams to moles and moles to grams. And how we do that is by molar mass. I told you that grams is your keyword to use molar mass. And that's not changing. That's still true for stoichiometry. Then we also have Avogadro's number. And so if we see atoms, molecules, compounds, that means we need Avogadro's number. In stoichiometry, we don't see that one as much, but you will still see it. And so you need to remember that. And so we're going from atoms, molecules, compounds, whatever, to moles, and then vice versa. Two new vocabulary words would be molar volume. And so molar volume is going to be the volume of 1 mole of a gas. And so what that is that's saying that it's 1 mole is equal to 22.4 liters. And so that's one of our new conversion factors that we will use. And so we have 1 mole is equal to 22.4 liters, okay? And so that's one of our new conversion factors that we will use for molar volume. Look at my big old belly. My belly button sticking out and everything. And then we also have molarity. And so molarity is going to be volume of a liquid. So we have volume of a gas, which is molar volume, and then molarity, which is volume of a liquid. And so molarity is similar, but a little bit different. It's moles per liter. And so I will tell you how to work it out and everything, and I'll do that in a completely separate video. But we have molarity, and so that will be its own little video to introduce molarity to you. And then we also have mole ratios, and mole ratios are going to be in your balanced equation. So you're just looking, just like your recipe. So I make chocolate chip cookies, and my chocolate chip cookie recipe calls for 2 eggs, and that makes 24 cookies. And so I have a 2 to 24 ratio. For every 2 eggs I have, I can make 24 cookies. And so just like that in your mole to mole ratios, you have the same concept. So you're looking and you're seeing, hey, if I have this much of hydrosulfuric acid, how much hydrogen sulfide, or that's the same compound, how much hydrochloric acid could I make, or vice versa. And so you're just looking at those ratios. So you're looking at your coefficients in your balanced equation. So that's the first thing that we're gonna do, is just learn some mole to mole ratios. So if I have this balanced equation above, which I'm about to write it. So if I say that for every 2 copper chlorides, I can react them with hydrosulfuric acid, and I can get out cuprous sulfide and hydrochloric acid. Okay, so then I have these compounds, and so I can do my mole to mole ratios. So if I want to know moles of copper 1 chloride is equal to moles of copper 1 sulfide, I'm just looking at the balanced equation. So I'm looking up here at this 2. So since there is a 2 in front, that means there's a 2 right here. And then this one, there's nothing in front, and so nothing means a 1. And so that is a 1-to-2 ratio. That is a 1-to-2 molar ratio. If I wanted to say, okay, well, what's the mole ratio of moles of H2S to moles of hydrochloric acid, I'd do the same thing. I would just look at what they have. So this guy has, hydrochloric acid has a 2 in front, so that means there's a 2. And then this one has nothing in front, and so that means it's a 1. And so again, it's a 1-to-2 ratio, but it's different compounds, and so it's a different ratio for each compound. And so you could do that with any of the compounds, and you need to be able to do that with any of the compounds in any balanced equation. And so that's how, so we have these new things. So we have molar mass, which is old. We have molar volume, molarity, and multimole ratios. So that's how you do multimole ratios. And then remember, molar volume is just 22.4 liters equals 1 mole. Molarity is the one that I'm going to do in the next video. So.